Hello dear all, welcome to the another video of series on the series of lectures on discrete mathematics. From our few videos we are studying the concept of relation and its type, and from this video we are going to start the new family of relation, that is symmetric, asymmetric and anti-symmetric. So in this video we are going to study the symmetric relations, and in our upcoming videos we are going to see the symmetric and anti-symmetric. So without wasting much of time, let's start our discussion. So before defining the symmetric relation, I am going to give you the example of symmetric relation which help you to understand the concept of symmetric relation in better way. So we have a set A which contains three elements A, B and C, and this is the matrix representation of A cross A. As you all know, the relation is nothing but a subset of A cross A or Cartesian product. So relation is nothing but a subset of Cartesian product, and the type of relation which contain the symmetric pair is known as the symmetric relation. Here I am going to give you the example of symmetric relation. The symmetric relation are those relation, or a relation is said to be a symmetric if relation contains AB, then the relation must need to contain BA also. So the relation is said to be a symmetric relation if it contains the symmetric pair. Here relation R contain AB, then the relation must need to contain BA because AB is symmetry of BA. Here in this diagram, I have colored each symmetric pair with same color. Here BA is symmetry of AB. Similarly, CA is symmetric of AC. Similarly, CB is symmetry of BC, and these diagonals elements AA is symmetry of itself, BB is symmetry of itself, and CC is symmetry of itself. So the relation on set A is said to be a symmetric relation if AB belongs to relation R, then BA also needs to belong to R. So in our next slide, I am going to give you the more examples which will help you to understand the concept of symmetric relation in better way. So here we have set A, and set A contains these three elements A, B and C, and this is the matrix representation of A cross A, and we have relation R. So we need to see whether this relation is, we need to identify whether this relation is symmetric relation or not. So here we have AB, so we must need to have another element, that is BA. So here we have AB, and the symmetry of AB is BA. So it's okay. Then we have another element, that is CA, but the symmetry of CA is A and C, but we don't have these elements in our relation. Therefore, this relation is not a symmetric relation. Why? Because we have element CA but we don't have AC. The symmetry elements of CA is AC. Therefore, in this relation we have two symmetric elements, but for this third element we don't have the symmetric pairs. Therefore, this relation is not a symmetric relation. So I am going to give you another relation. So first let me erase whatever I have written. So here in R2, here in R2 we have first element AB. So we need to have its symmetry elements, that is B, A. We need to have B, A. That is the symmetry of AB. Symmetry of AB is BA. So we have this element BA here. So we have another element, that is BC. The symmetry of BC is CB. So we have CB here. And we have CB here. And we have another element. So we have another element, that is AA. So we have learned that this diagonal element AA is symmetry of itself. So we have, for AB we have BA, for BC we have CA, and for AA is symmetry of itself. Therefore this relation is a symmetric relation. Now we have another relation, that is another relation R3, which contain three elements AA. So AA is symmetry of itself, BB is symmetry of itself, and CC is symmetry of itself. Therefore this relation R3 is also a symmetric relation. Here we have another relation, that is R4, which contain nothing. So this relation is known as empty relation, or we can use to denote this relation as phi. So this relation is symmetric or asymmetric relation. We can say that this relation contains nothing. Therefore it doesn't contain any element, so that this relation is also a symmetric relation. So this relation R4 is also a symmetric relation. So we have another relation R5, which is A cross A. So this R5 contain all these elements AA, AB, AC, BA, BB, BC, this element, this element, this element, all element contain this. So this relation is also a symmetric relation because it contains AA, BB, CC, and BA, then BA, AB, CA, and AC. So it contains all the symmetric pairs. Therefore this relation is also a symmetric in nature. So the relation is said to be a symmetric relation if a relation contains AB, then it must need to contain its symmetric pair, that is BA. So here these are the symmetric pair. BA is symmetry with AB, CA is symmetric with AC, CB is symmetric with BC. So the relation which contains this symmetric pair is known as symmetric relation. And one thing we need to remember, that this diagonal element is symmetric with itself. So this is all for today's lecture. See you in next video. Thank you.